Now that we know a little bit about multiplying positive and negative numbers, let's think about how we can divide them. And what you'll see is that it's actually a very similar methodology, that if both are positive, you'll get a positive answer. If one is negative, but not both, you're going to get a negative answer. And if both are negative, they will cancel out and you will get a positive answer. But let's apply it. And I encourage you, pause this video and try these out yourself and then see if you get the same answer that I'm going to get. So 8 divided by negative 2. So if I just had 8 divided by 2, that would be a positive 4. But since exactly one of these two numbers are negative, this one right over here, the answer is going to be negative. So 8 divided by negative 2 is negative 4. Now negative 16 divided by positive 4. We have to be very careful here. If I just had positive 16 divided by positive 4, that would just be 4. But because one of these two numbers is negative, and exactly one of these two numbers is negative, then I'm going to get a negative answer. Now I have negative 30 divided by negative 5. If I just had 30 divided by 5, that would be positive 6. And because I have a negative divided by a negative, the negatives cancel out, and so my answer will still be positive 6. And I could even write a positive out here. I don't have to, but this is a positive 6. A negative divided by a negative, just like a negative times a negative, you're going to get a positive answer. 18 divided by 2, and this is a little bit of a trick question. This is what you knew how to do before we even talked about negative numbers. This is a positive divided by a positive, which is going to be a positive. So that is going to be equal to positive 9. Now we start doing some interesting things. Here's this kind of a compound problem. You have some multiplication and some division going on. And so first, right over here, the way this is written, we're going to want to multiply the numerator out. And if you're not familiar with this little dot symbol, it's just another way of writing multiplication. I could have written this little x thing over here. And what you're going to see is in algebra, the dot becomes much more common because the x gets used for other things. Or there's not the times symbol, people don't want to confuse it with the letter x, which gets used a lot in algebra. And so that's why they use the dot very often. So this just says negative 7 times 3 in the numerator, and then we're going to take that product and divide it by negative 1. So in the numerator, negative 7 times 3, positive 7 times 3 would be 21. But since exactly one of these two are negative, this is going to be negative 21. And it's going to be negative 21 over negative 1. And so negative 21 divided by negative 1, negative divided by a negative is going to be a positive. So this is just going to be positive 21. Let me write all these things down. So if I were to if I have a positive divided by a negative, that's going to give me a negative. If I have a negative divided by a positive, that's also going to give me a negative. If I have a negative divided by a negative, that's going to give me a positive. And if I have, obviously, a positive divided by a positive, that's also going to give me a positive. Now let's do this last one over here. This actually is all multiplication, but it's interesting because we're multiplying 3 things, which we haven't done yet. And we could just go from left to right over here. And we could first think about negative 2 times negative 7. Negative 2 times negative 7, they are both negative. The negatives cancel out. So this will give us, this part right over here, will give us positive 14. And so we're going to multiply the positive 14 times this negative 1. Times negative 1. Now we have a positive times a negative. Exactly one of them is negative. So this is going to give me a negative answer. It's going to give me negative 14. Now let me give you a couple of more, I guess we could call these trick problems. What would happen if I had 0 divided by negative 5? Well, this is 0 negative fifths, or 0 divided by anything that's non-zero is just going to be equal to 0. What if we were to do the other way around? What happens if we said negative 5 divided by 0? Well, we don't know what happens when you divide things by 0. We haven't defined that. There's arguments for multiple ways to conceptualize this. So we traditionally just say that this is undefined. We haven't defined what happens when something is divided by 0. And similarly, even if we had 0 divided by 0, this is still undefined.